Okay, so in this series of questions, we're going to be looking at this whole process we're doing with growth, a percent increase or percent decrease, as a function, an exponential function. So there's going to be an exponent involved because we're going to do the same rate of change, the same percent of change multiple times. So to get us first sort of familiar with what we're doing, we'll take a look at this question 39a. And this is just some abstract way of thinking of it. You might have done this in an algebra class before, but just sort of follow along. We're going to use function notation, and when we have this little f, we say there is some function. We'll plug in a value, and we'll get a result. So this first question, the function we're using is 24, 0.72, and we're going to do that change, the percent change, multiple times, x times. Actually, back up here. We're going to have an exponent up there. So we look at this question. We're starting with $24, 24 somethings. We are actually losing, right? This is a percent decrease. We're getting 72% back, which means we are losing 28% decrease. And what we're going to do is we're asked to do three parts. First asked to plug in -3, which means we went backwards 3 times. So if you do a decrease backwards, you should get an increase, right? So if we do this calculation, 24 times 0.72 raised to the -3 power, which is 24 times 0.72, use the exponent key, -3. And what you should get is 64.3. Okay, we actually increased it 3 times because we went backwards, the negative. This was the A question. The B question, we're going to do the same function. Same setup, but this time they ask us to plug in the value of 0. So this should give us at time 0, nothing has changed. We should get back to the original value. And go ahead and plug that in your calculator. In fact, if you want, you can plug in 0.72 raised to the 0 power. You'll see you'll get 1. 1 times 24 is 24. Or do it this way, 24, 0.72 raised to the 0 power. And what do we get? We get 24. Okay. And finally, the C question. We want to take this function and we want to plug in the value of 2. So we're going to change twice. So again, we've got 24, 0.72 raised to the 2 power. So in our calculator, that's 24 times 0.72 raised to the 2nd power. We have decreased 2 times, so we'll definitely have less than 24. In fact, we'll have 12.44. Okay. So that's 39. 40 gives us a similar experience with functions. But in this function, we've got an increasing one. So I thought it was good to go ahead and take a look at it. So the A part, we're asked to take the function, plug in a value, and the function we're given is 5 times 1.08 raised to the x power. And again, sorry about this. Rather than putting the x there, what we put is that's where we're going to plug in. Whatever's in this parentheses goes into that parentheses. So -1. Again, remember that's going back in time, 1 day, 1 year, whatever this is. We start with $5. We're increasing by 8%, 100 plus 8%. So that's what's going on here. 5 times 1.08 raised to the -1 power. And when you do that, you'll get more. Actually, we'll get less than 5 because we're going backwards, right? So we get 4.63. Okay. The B part, using the same function, in this case, we're asked to plug in 0. And this is very important value. This is the initial value, isn't it? Times 0, we should get 5. And when you do the calculation, it definitely, you get 5. Times 0 gives us 5. And finally, if we increase in our time, so B, C, we're going to take the function value 3 years down the road. So we put our $5 into the bank account. We're getting 8% interest in 3 years. What do we have? 5 times 1.08 raised to the third power. And we'll say we've increased to a whopping $6.30. Okay? So those are the calculations with exponentials. What we're going to do now is look at a series of questions that give us the exponential equation and ask us to identify some aspects or some features. So 41 here, we're given f of x equals 170 times 0.8 to the x, and they want the initial value. Okay. Initial value, just like we were looking at these, is always that number in front of the factor. So it's going to be 170. And you could find that with your calculator if you want by plugging in 0 for x, just like we did on 39 and 40. This is the B question. Plug in 0, you get your initial value. The B question, looking at it, is identify the function's behavior as growth or decay. With a factor 0.8 in the parentheses there, that's indicating it's less than 1. This is decreasing function, so it's a decay. Again, because of the 0.80. That part, that's decreasing. That causes the decrease. See, identify the growth or decay factor. Well, that is the factor. Got ahead of myself. That's the factor. And the final question is we look for the rate. Well, remember this, we have to subtract it from 100. Or you have to subtract 100 from it. So you take 80% minus 100%, and you'll see it's a negative 20% rate. So as a percent, negative 20%, or you can say it's a 20% decay. Either way works. Okay. 42. We're asked the same 4 questions on a different function. 5 parentheses 2 raised to the x. Okay, so what's the initial value? In this exponential, 5 is first. If you put a 0 in for x, you'll see that your initial value is going to be 5, that number in front. The question, is it growth or decay? We'll look inside. 2 is in that parentheses. So 2 is greater than 1. This is growth. Increase. What's the growth or decay factor? The growth factor. The factor is the number in there. That's 2. And what you want to see that is actually like 200%. Not just like 200%, it is 200%. So for the D question, what is the rate as a percent? It's 200% minus 100%. I see I missed my percent marker here. That should be a percent. So it's actually a 100% increase. So when you're doubling, you're increasing by 100%. 43. We're given the function 110 times 1.3 to the t. So in our initial value is the number in front, the 110, plug in the 0, but you'll see that that is consistently what we've been doing, right? This is our starting value. 1.3, that's the function. It's bigger than 1, so we know we have growth. See question, what is the factor? It's that thing in the parentheses, 1.3. That's its factor. And what is this? This is 130%, sorry. if you subtract the 100%, which is what we started with, this is a growth of 30%. Okay, and so that's our rate, 30% growth. So that's starting with an equation, being able to tell what we have as far as rate of growth or decay and what we started with.